one? What another idea? All right, so what do you think I'm going to do this time?
So you divide everything by y.
And yet another idea. Oh, yeah. Did you say it wrong, or did I just write it wrong? So again, you don't have to be able to do these proofs. We're going to do more proofs through the unit. Okay, but you need to be comfortable following a proof. And I think when some of you go off to university, if you take math-related programs, you'll be doing proofs yourself. All right, so all of these are on your reference sheet. You notice the 3 reciprocals at the top, the 3 Pythagoreans up the top. There's the 2 quotient identities. Okay, we'll add some more of these as we work through this unit. All right, so now we want to do some proofs. Keep that sheet close at hand. You'll be using it through all of the proofs that you do. And I have a list of strategies for you. And don't get the impression that there's only one way to do a proof, that there's only one correct answer. There's lots of paths to get there. There's lots of correct answers. And don't get the impression that when I look at a question that I immediately know what the right answer or the right path is. It's what I happen to notice that way. So some of the strategies I have for you are to convert everything to sine thetas and cos thetas, likewise sine squares, cos squares. Get rid of anything that's not a sine or cos.
So if we were going to convert it, will we use like these?
Yes, so for example, if I had tan in my question, I might say, okay, I'm going to take tan out, and I'm going to say sine over cos instead. Okay. Another one would be to use the identities on the sheet and use them for substitution. Yeah, I got it. No, I got it. fractions in a question, and your things are being added, use your fraction skills, common denominator, okay? So bring in your other core skills. Thank you. Use your factoring skills. Just to recap, what skills of factoring do you have? Say again? Complete the square takes a question into vertex form. It doesn't factor it.
Oh, wait, that's not.
Selling product? Any more you can remember?
Isn't there like common factor?
Common factor?
That's what I'm talking
Didn't we like differences for stuff?
Yeah. The process of completing the square uses factoring within it. Perfect squares. So another one. Use a form of one.
What does that mean?
Okay, I won't give it to you in terms of an actual identity example, but I'll try to give you a basic idea what I mean. Again, it's just an attempt to get you to understand what I mean. If I have something, what can I times it by and not change it?
One.
One. That's what I mean. You can times it by one, and it's still the same question.
But then what's the point of doing that?
It's kind of tough for me to give you an actual example without us actually doing identities yet,
Oh,
okay? But this is allowed. You can times stuff by one, and you can choose whatever form of one you want. Okay, that's the power of it. You can times it by one, doesn't change the question. You get to pick the form of one. So in a lot of cases, choosing it based on what your denominator is a good strategy. That's the best I can give you until we get an actual question. The other thing I want to remind you of, the only time you've probably seen an actual proof would go back to grade 9 when you were doing solving equations and you were asked to do a left side, right side check. Remember ever doing one of those?
No.
Yes, no?
No.
Okay, well that would have been the beginning of getting you into the proper notation. So I'm just going to emphasize that proofs have very specific notations. So in other words, what are you going to do when you do your work? Or better yet, what am I going to be doing? Get your form right. How appropriate I chose to put one of those guys up there. Okay? One thing is, step one, you always take the original question